Good afternoon, everyone, and welcome to today's webinar, Evolution and Improvement in Spacer Technology for Freezing and Storing Palletized Product. This is brought to us by FPSA member company, Tipman Innovation. Our speaker today is Dan Tipman. Dan is the owner and principal author of Tipman Innovation. My name is Dolores Alonso, and I'm the VP of Membership here at FPSA. This webinar is being recorded, so for those of you that are FPSA members, let your colleagues know that they can listen to it via the members only section of the website, and it's in the recorded section there. And for those of you that are not FPSA members, I'm happy to provide you a link to it after, so just let me know, shoot me an email. I think we are pretty much ready to go, so I am going to switch this over to Dan Tipman. It'll take a second or so, and we will see Dan's screen shortly.
Thank you, Dolores.
Sure thing, Dan. Thank you.
All right, and thank you to everyone who took time out of their day to listen and be part of the interactive presentation. So I'll jump right in. Everyone that serves the food processing industries, they know how important it is to provide fast and consistent results when you're doing either product freezing or product tempering. And clearly a key component of that is spacer technology. And it's something very few people really consider, but hopefully we bring out a couple points today that are helpful, useful, and can affect future decisions. So we first think, what are freezer spacers? And really they're just rectangular shaped dividers shaped to provide some vertical distance between our layers of case product. So everyone looking at the pallet on the left, is pretty obvious if that was fresh freeze product and you put that into your freezer, the innermost cases are going to be very challenging, very time consuming to freeze, and you just wouldn't get good quality results. So we insert spacers to give us that vertical separation, hopefully to get the right amount of air between it to get our heat transfer that we're looking for. So what are the alternatives to freezer spacers? Well, many products have holes in the boxes. I think of hams and turkeys, where if you're able to get sufficient air through the boxes, you don't necessarily need layer dividers. You can also stack the product so that you can get sufficient airflow between the cases to be able to get good freezing results. That's often a very labor-intensive option because most of the time you have to change the tie or the number of cases per layer in order to provide enough space between the cases, and then obviously you probably have to return those layers back to a full layer to be able to ship the product. And then obviously there's other technologies, either IQF of the product or individual case freezing, plate freezing, VRT, those other solutions. But we're going to be focusing exclusively on case and palletized products that require spacers. So really, why do we need or use the freezer spacers? Again, the spacers enable the freezing of the case palletized products by providing a multitude of airflow passages within the stack. And further down in the presentation, we'll discuss the importance of the number of airflow passages versus the height of the case product. So what other functions do we need the spacer to do? Number one, the spacer has to be able to support all of the products above them. So if the cases are forming around the spacers and cutting off the air supply. That's a problem. Uh, and of course, they have to provide the vertical separation for the airflow we need. So when we look at a pallet, here's a little wireframe pallet. Um, we really want every case in the stack to freeze at the same rate. So I've just picked out two cases. The first one is upper right. That exterior exposure case, most people have very little problem freezing a case in that position on the pallet. Where further down in the pallet, midway and lower in the pallet can be challenging if your spacer is not performing well. So again, we need to have it properly support all the cases that are stacked on top of it, above it, and it provides sufficient airflow space to get the heat transfer done. So now, next I'm going to talk about challenges that are faced by all spacers. So the first thing I want to discuss are case and pallet dimensions. I call it the double whammy of the tall case, where tall cases require longer dwell times because there's further distance to center, and it just takes longer to freeze the taller case. And then the other thing that really hurts us is taller cases allow for fewer spacers. So in a few slides, I'll show you two examples. And then the next thing that we all are challenged with is the accumulated weight causing a crush challenge. So here's two cases. I have a 10 kilogram and 15 kilogram. This happens to be details from a leg quarter project. Notice the 10 kilogram case is 3 3/4 inches tall, while the 15 kilogram case is 5.5 inches tall. And this is a 7-tie box, so the base dimensions are the same, 20 inches by 13 1/4. So when we put these cases into pallets, we end up with somewhat similar looking stacks, but when we consider what we're faced with, the shorter case on the left, the 10 kilogram case, the weight of the product is just over 2,000 pounds, but we're able to get 13 spacers into that stack. While the pallet on the right, the 15 kilogram box, the taller box only yields a 9-high arrangement, so we have 9 spacers. So in both of these, we do have a spacer on the bottom. Some people omit those, some people include them. It really depends on testing whether it's needed or not. But now we have 9 airflow passages versus 13, and the distance to center on the taller case hurts us. So that's why I call it the double whammy of the tall case dilemma. So we have data that shows these two, the performance of these in about a -15 freezing arrangement. So the shorter case with more spacers, they're able to turn in 18 hours with a 0-degree core temp, while the pallet on the right, the taller cases with fewer spacers, that's 1/3 more hours to freeze the pallet on the right. So you can tell that the tall case really does have a significant effect. So when we're doing freezing or tempering, clearly we're looking at box height as a very important consideration. The next challenge is something most everyone can go view. If you're doing a considerable amount of freezing or tempering, start watching your pallets. Make sure they're they're performing like you're wanting them to. And here in this example, I grabbed that 13 spacer pallet just to show that the top spacer is only bearing 154 pounds of product above it. So obviously we're not expecting uh, crushing at that top layer. Then obviously you pick up 154 pounds per layer moving downward. So at the very bottom, we're expecting between the bottom two layers of product, that spacer is now bearing 1,848 pounds and is very prone to crushing. So here's a photograph of product, and it shows us what we often will see. And for someone that's doing product freezing or tempering, uh, these these kind of pallets really become challenging. You can see the significant space near the top of the stack. In fact, on the second layer, I can actually see through the pallet and see the panel wall. So I can see we have great open area. That spacer's doing a great job. Really on the top, about 6 layers, it's doing a great job. And the looks like the bottom 3 layers, there's significant crushing. And really what uh, we see more case failure causing the crushing than spacer failure. And we'll discuss this further, but we're going to touch on case carrying area and why that's important for case integrity. So here's a couple other views of that same pallet. And you can see on the photograph on the left how really the bottom 3 layers, there's virtually no uh, visible space for air to be going through that pallet. It's virtually cut off. Uh, so if you're trying to get fast and consistent results, and you're faced with this accumulated weight and failure of your corrugated box, you can expect a significant difference in performance in this single pallet. Not to mention uh, how the rest of the pallets in your freezing system are operating. So I think it's fair to say the best way to deliver fast and consistent results is to provide excellent velocity in all layers. So now we're going to jump into kind of some history, some different styles of um, dividers, spacers, slats. There's several different names people have used, and I was actually able to find photographs of a current facility using wooden slats. So I have a slat picture here, and now I'm going to list advantages and disadvantages of a multitude of styles, and I think we kind of all agree that the wooden slat it itself does not really crush. Just a fabricated wood arrangement. It is fairly low profile, so it doesn't add significantly to the stack height, and the initial cost is very affordable. I think we can all recognize some of the distinct disadvantages. Obviously, it's somewhere between difficult and impossible to sanitize. So if you have a product that, if you're freezing or tempering product that's purging, where you're getting your spacers wet, exposing them to liquids coming from boxes, this is a challenging solution. Another thing that's important, and you can kind of see there's a stack in the background. Obviously, these don't nest well when they're stacked. Um, the plastic spacers that we'll see really do tend to nest quite well. Uh, these do typically have a short lifespan, So probably on the order of 10 to 12 cycles, and these are probably going in the scrap pile. Another thing that's concerning to some users is uh, these do contain staples, and when they're coming apart, the staples can land in the cases and get shipped. And lastly, on the disadvantage side of the wooden slats is they have a reputation of being difficult to remove. So if you notice when you bring your frozen stack out and it goes on a tilt table to remove the spacers, these can be stuck very well to cases, and they're hard to remove. The next one is kind of an aluminum version of the wooden slat. So we'll call it the aluminum spacer slat. So on the advantage side, I think we would all agree that this looks like a very durable item. This is looks like extruded aluminum components, and they are welded together. So I would expect this to be a very sturdy, very durable spacer. Next, this isn't prone to deforming, so it's going to act more like a tray, so it can actually carry weight very well. Uh, the material has good conductivity. Aluminum is a great conductor, so you do get some additional heat transfer just because of the material. Um, on the disadvantage side, these things are very expensive. They're hundreds of dollars first cost. Next thing, obviously, they don't nest when you stack them. There's they're going to accumulate their actual height. The next thing is the low case contact surface area makes it prone to case crushing. So even though we're not going to crush the spacer, they are going to be prone to case crushing. The egg crate spacer is probably the spacer most people are most familiar with, and obviously it gets its name from its similarity to an egg tray or egg case. So the advantages are low first cost. These things are, if you're buying quantities, you might be buying them for $5 to $6. So they're low first cost. They are fairly low profile. They're typically 1.5 inch dividing height. They nest well when you stack them. They are easy to clean, sanitize, and they are food safe, HDPE, high density polyethylene. The disadvantages, these are notorious for crushing problems. Very poor case carrying support area, and their airflow passages, they're easily cut off by cases that are crushing. So I'm going to call those poor airflow passages. The next spacer we're going to look at, I'm going to call the maxi spacer. I think that's a trade name of this, but there's a host of taller spacers. So this is just kind of a family of taller spacers with a non-egg crate profile. So just the height advantage, I think these are like 2.5 inches tall. So just the height advantage helps cases not deform to the point where they're going to cut their own air supply off. But with some of the photos I showed before, do show the maxi spacers being cut off. So, but we are going to give them an advantage of improved airflow passages because the profile is taller. These also nest well when stacked. Again, they're easy to clean and high density polyethylene. The disadvantage, they're moderately higher first cost versus the egg crate spacer. They too have poor case carrying support that leads to case crushing, and the tall profile adds to stack height. So I think we're looking at the egg crate spacer at 1.25 inches. This is basically twice the height. So some people use these on on products that they've had performance challenges with egg crates. They go to these and they do get better results. However, the accumulated height can drive the height of the stack up to the point where it has trouble. They have trouble fitting these into their freezing system, and they may have to take a layer off to make it fit. So for some people, that tall profile and accumulated height is a distinct disadvantage. The next one is the T2 spacer. This is a one direction airflow spacer. So notice on the other spacers we were able to go airflow in both directions, both sideways, both the 48-inch and the 40-inch direction. This spacer, you only have airflow in one direction, and if you consider the design of blast freezers, the intended airflow pattern is exclusively in one direction. So that's the thinking behind the T2 spacers, to accommodate that single direction airflow. So an advantage is improved airflow passages. So it's more of a straight through, high flow profile. It too nests when it's stacked. It is easy to clean, and excellent airflow passages. The disadvantage there, it is higher first cost versus the other plastic spacers. Now I'm going to spend some time on some more photographs, kind of documenting and contemplating some of these challenges. So these are the photograph on the left. You can see the white top case that's in the middle of the photograph. The bottom of that case is well below the top of the case it's sitting on. So this is virtually cut off. You can see on the photograph on the right, the protrusions of the taller spacer. This is a maxi style spacer. As the profile is going up the sides of the case, that clearly shows that the pattern is deforming the bottom of those cases. So virtually every one of the layers shown in the photograph on the right are cut off. And when we look at some of these photographs, one challenge we have to consider is who is putting in the spacers? Where are they being put in? So if this happens to be a public refrigerated warehouse and they are 100 miles away from the processing plant they're serving, if the spacers are going in at the plant, they have a much higher probability of significant crush issue if they bounce down the road 100 miles and end up at the third-party provider. That's why many of these, especially high-turn poultry facilities, they insist on or really prefer to insert and remove spacers at the facility. That gets them away from having to return spacers to the plant and account for spacers. But the big challenge is helping to prevent case crushing in transit. So here's a couple of extreme photographs. These are 60-pound cases of pork trim, and they have just destroyed the spacers. This photograph, you can barely tell there's spacers in there. If you weren't looking for the black spacer between the layers, you'd be hard pressed to identify that it could possibly be in there. So there's no freezing system out there that could hope to get any meaningful air between these cases. So the things that are contributing here are, number one, the corrugated is just not holding up. And when this pallet is tied together like it is, so you're alternating the pattern layer by layer, that puts the corners of the boxes into the into a non-corner of the box below it. So when the corners of your corrugated boxes are landing on the lid of the case below it rather than on a corner, then you can expect your crushing on your heavier, denser case to become more pronounced. So here's what that product looked like. It had to be rethrown to to be able to be worked, but you can tell that the spacer was significantly deformed, and the cases associated with this crush are significantly deformed. So you can see what the cases above it did to this bottom layer of product. The cases on the left are uh, dented in probably on the order of 2 inches. And then obviously the case closest to us in the photograph, that it actually exposed the product inside the case. So this is an extreme example, but it happens. And if you're providing freezing or tempering services, clearly we need to watch for and communicate and resolve problems with the spacers, because clearly this product or anything like it can't expect to be uh, frozen in a quick or consistent manner when there's just no realistic chance of getting airflow through there. And I've mentioned tempering a few times. We really face the same problems with freezing, but it actually can be significantly worse, because when you're tempering, you're obviously using air temperature that's above the freeze point of the product. We're trying to thaw the product. So when we're tempering, we're tending to relax the product, which often makes the case wet. So the case tends to relax down over the spacers, and obviously the same problem we're trying to fight here. It's cutting off its own air supply. So it's it's really important to be able to properly carry the weight of the products without cutting off the air needed to freeze or temper that layer of product. Here's a quick video on a spacer removal. It's a semi-automated arrangement. So you can see the case is being conveyed onto the tilt table, and the operator is going to tilt that pallet back. You can see he has a pallet up front that's already being wrapped, and it will automatically convey out. But he'll move a couple bands of wrap out of the way to be able to pull the spacers out. If you see, there's a stack of spacers behind him, so he'll just wrestle these out, stack them on the pallet, and be able to move on. That really concludes my presentation. Hopefully, we've drawn attention to some of the more important considerations, and kind of understand some of the spacer technology uh, improvements and different ideas people are using. And it really comes down to, we need to provide that excellent velocity between every layer to deliver those fast and consistent results to our customers.
Great, Dan. Thank you so much. I have a few questions from folks. So I'll start with the first one. Do all palletized products require spacers for freezing?
Well, most do, but again, if there's holes in the boxes or the arrangement is stacked so that there's sufficient air flow between cases, and that especially if the case is tall and there's lots of side contact area for air to go by and grab the heat, then you wouldn't necessarily need layer dividers or spacers.
Okay, great. Thank you. And then second question, do pallet spacers have an average lifespan?
They do, and the people in this industry they call them cycles, and the depending on the durability, the design, the profile, uh, I think people get between probably 30 and 100 cycles. So it really depends on how well they're treated. Um, there's a lot of contact when they're loading and unloading, especially at low temperature. You can tend to tear up the edges of the spacers.
Okay, great. And I have a question from John Jaffke. It says, good presentation, Dan. And I may have missed it, but what material is the T2 spacer made of?
The material is high density polyethylene. It's a food safe material and it works well in the cold. So that's why it's kind of the go-to material for plastic spacers.
Wonderful. And also, Dan, just let's make sure that we get your contact information to everyone. And I can email that out after. I just got a few comments regarding that.
Okay.
The next question, from a food safety standpoint, is there one type of material which is better to use for pallet spacers?
I think it's a consensus in the industry that the one piece high density polyethylene spacer is the easiest type of spacer to sanitize. And I'm just thinking of that aluminum fabricated spacer. I could see where a food safety specialist would say, "Gosh, I don't like those crevices and holes in the center of the extruded parts." So yeah, I think the one piece, uh, either injection molded or uh, vacuum formed, high density polyethylene is probably the material that's easiest to sanitize.
Okay, terrific. And then finally, what do you mean by case carry area?
All right, case carry area. Let me see if I can go upward in the presentation. If I look at, okay, I'm going to the egg crate spacer uh, photograph on the right of uh, this slide. And if you look at see the top portions of the egg crate, they're kind of reflective. That's the area that engages the bottom of the case. And an egg crate spacer, and really virtually every spacer that allows airflow in the two axes, they have about a 25% engagement area. So in your 40 by 48 arrangement, you have around 15 square feet of possible engagement area. These are around 6 square feet, so it's about a 25% engagement with this style spacer. Very true in this arrangement. So again, the spacers that provide two-axis airflow, they they're kind of sacrificing case carrying area for that two-axis airflow. And when you look at the T2, they have almost 50%, almost twice the case carrying area. So we're trying to do a better job of uh, carrying the bottom of the corrugated boxes so they don't tend to deform and cut off their own air supply. Does that make sense?
Excellent, great. Thank you, Dan. I think that does it with the questions. So we're gonna thank our attendees for taking the time out today, and Dan will be reaching out with his contact information shortly after the webinar ends. So thank you again, everyone. Dan, thank you so much.
Thank you. I appreciate your time.
Take care, everyone.